This presentation covers the installation of composite floors as part of the light steel package. Here's some information about the spans and depths of composite floors. They may be used as an alternative to joisted floors, but they're much heavier, typically around about 300 kilograms per square meter. Slab depths range from 130 to 200 millimeters, depending on their span. Steel decking may be in two types, either a reentrant or trapezoidal shape. The span to depth ratio of the slab should generally be less than 30 to control deflections, so it follows that a 5 meter span is achievable for a 170 millimeter deep slab. The decking can support concreting loads for spans up to about 3 meters for reentrant decks and 3.5 meters for trapezoidal decks. And finally, props and spreader beams or timbers are required where unpropped spans are exceeded. Here we see three types of decking. In the top, the reentrant shape, generally round about 55 millimeters deep, with the center-to-center spacing of the ribs of 150 millimeters. Secondly, a trapezoidal profile with a slight reentrant stiffener to allow for attachment of the service hangers. In this case, the center-to-center of the ribs is 300 millimeters apart. And finally, a trapezoidal profile, again of similar shape, in this case 80 millimeters deep. Here we see an example of safe fixing of decking, in this case 80 millimeter deep decking. The operative is fixing the edge trim to the end of the span, and for this operation he is fixed by a safety harness to a lanyard. It's also possible for steel decking to be delivered with crushed ends that can be placed on light steel walls, as shown below. And this means that it's possible to prevent loss of concrete from the ends of the decking. So regarding reinforcement in composite floors, mesh reinforcement of 0.2% of the topping area is placed to control cracking, and this leads to a mesh area of around about 193 millimeters squared per meter length in both directions. Now, mesh can provide continuity for fire resistance of up to 2 hours for spans of up to about 3.6 meters. For longer spans or for single span decking, it's necessary to use additional bars in the deck ribs, and these are typically 12 millimeters diameter. It's also necessary to provide tie bars where beams cross the slab within the slab depth. And for vertical tying action between walls and the floor, it's often necessary to use threaded bars, typically 10 millimeters diameter, to provide continuity in the vertical direction. Steel beams, such as rectangular hollow sections, may be integrated into the floor slab, as shown here. And in this case, it's necessary to pass bars through the holes in the web of the RHS sections to provide for continuity. Regarding propping of composite floor slabs, as shown on the right-hand side, it's generally required to use a single line of props for spans more than about 3.5 meters, and a double line of props for spans more than about 4.5 meters. Props are generally placed at not more than 1 meters apart in the transverse direction. And timber spreaders should be used below the decking and shouldn't be less than 100 millimeters wide. And props should be left in place until the slab has gained its full strength. And often it's required to prop to up to 3 floors below when the self-weight of the slab is quite high. Concrete placed on steel decking is generally a pumpable mix. In some cases, self-compacting concrete may be used to minimize vibration and tamping. The specified cube strength or cylinder strength C2530 is generally used. And it's necessary to identify if power floating of the slab is required, as this should be done as soon as the concrete is hardened. The gain of concrete strength is generally 70% after 7 days, which influences the ability to deprop the slab. And finally, props are continued to 2 or sometimes 3 floors below, as the imposed load that the slab is designed for is significantly less than the slab self-weight. Here we see the concreting operation by pump. So some other features of composite floors are as follows. Services can be placed below the floor and are suspended from the decking. Pipes of up to 150 mm diameter may be drilled through the slab and detailed with suitable fire dampers as they pass through the slab. However, service risers and larger openings should be detailed into the decking layout before concreting. A fire resistance of up to 2 hours can be provided by use of additional reinforcement. And this leads to the use of a single layer of plasterboard. And finally, although the acoustic insulation is very good, control of impact sound may require the use of a resilient layer on the top of the slab. And here are some examples of holes drilled in a slab for services. And also ducts may be suspended from the little reentrant stiffeners as part of the deck profile. So what have we learned about composite floors? They lead to relatively thin floors, up less than about 200 mm, but the self-weight is 3 to 4 times that of a joisted floor, which therefore increases the loads on the walls. And slab spans should be less than 30 times the slab depth to control deflections. The construction cycle is slower than that of a joisted floor because of the ability of the concrete to gain strength and to remove props. It has good fire resistance, which means that a single layer of plasterboard may be used below the floor, and services may be suspended below the slab. Holes have to be drilled or core cut for vertical services. And finally, impact sound insulation requires the use of a resilient floor covering.